This problem is based on splitting of d orbital and the tetrahedral field. Question is the number of unpaired electrons present in cobalt Cl4 2- is the given options are 1, 2, 3 and 4. It is very important to calculate the number of unpaired electrons. Based on that, you can predict the magnetic moment. In order to predict the number of unpaired electrons, we split the d orbital under the octahedral field or tetrahedral field and we fill the orbitals with electrons following certain basic principle. When you go for octahedral field, you will get low spin as well as high spin complex. But when you go for tetrahedral field, you will get only high spin complexes. The reason is the difference in energy between the two levels will be very less in tetrahedral field. It will be only 4/9 of del O. If you go for del T, that will be only 4/9 parts of del 0. Since it is very less, the electrons will prefer to go to higher energy level than pairing. Because of that, tetrahedral field always results in high spin complexes. In order to solve this, you should also know to find out oxidation state. Here, say cobalt, you have to find out. We have 4 Cl-, each contributes -1. The charge on the complex is -2. So what I get is x minus 4 is equal to -2, x is equal to +2. So the oxidation state of cobalt is +2. Go for cobalt, the electronic configuration will be 3d7 4s2. But for cobalt 2 plus 3d7 4s0, I have to remove 2 electrons from s orbital. Now I have to place the 7 electrons in the splitted d orbitals. And a tetrahedral field, it is getting splitted into E and T2. There won't be G. G refers to gerade. In tetrahedral complex, there is no gerade. There is no center of inversion. Because of that, E and T2. When you go for octahedral field, it will be reverse. You have to go for T2G at the bottom, EG on the top. Say this is the barycenter. This will be 6 dq. This will be 4 dq. Now I place the electrons. I place singly first. Since the energy difference between E and T2 is less, I have 2 more that I place here. So now the number of unpaired electrons is 3. They are present in T2 orbital. Instead of this, if you place 7 electrons directly in this, then also you will get 3 unpaired electrons. So you can go for this kind of calculation in tetrahedral complex, but when you go for octahedral, this may not match. Depending on the ligand field, you may get high spin as well as low spin complexes. Because of that, you cannot apply this strategy in octahedral complexes. So what I advise is go for the splitting, then fill the orbital.